All right, let's have a look here at this question. So the first thing here, circle S and K touch externally. Circle S has center 8, 5 and circle K has center 2, 3. Calculate the radius of K. So we should first calculate the total distance between the centers, which is square root 6 squared plus 8 squared. Well, that's convenient. That's square root 100. So that's 10. Okay. So, well, that kind of answers our question. If this has radius of 6, then it means the radius of the smaller circle has to be 4 because the total distance here to here is 10. So that's pretty straightforward. Find the equation of the tangent to this circle at this point. So the situation is first we'll get the slope. So that's 2x plus 2y dy dx equals 0. That means m is dy dx at the point. So solving here, that is minus x over y at the point, which is minus x1 over y1. And now the equation of the line, y minus y1 equals m times x minus x1. Multiply by y1. So you have y1 minus y1 squared equals minus x1 plus x1 squared. So you have x1 plus y1 equals x1 squared plus y1 squared. Taking the y1 squared to the other side. But in fact, that's r squared. So you have the result x1 plus y1 equals r squared. So let's clear that off. Hence or otherwise, find two values of b such that this line is a tangent to this circle. So let's see now. Remember we had the formula xx1 plus yy1 equals r squared. So for this circle here, it's going to be xx1 plus y y1 equals 169. And they have the equation 5x plus by equals 169. So therefore, the x1 is 5. And to solve for the y1, it must be true that 5 squared plus y1 squared is 169. So that means y1 squared is 169 minus 25, which is 144. So that means y1 equals plus or minus 12. So I think that's okay. And two values of b. Okay. A circle passes through that point and the line x equals minus 1 is a tangent. Find the equation of the circle. Alright, let's draw that now. So x equals minus 1 is a tangent line. And then the point 7, 2 and 7, 10. Oh, sorry, I've drawn it the wrong side. 7, 2 and 7, 10. That's a 2. That's a 10. That's at 7. That's x. That's y. The circle passes through those 2 points, 7, 2 and 7, 10. And x equals minus 1 is a tangent. Find the equation of the circle. So it's not exactly a great picture, but you know, that's kind of the idea. Something roughly like that. This one is a bit tough now. Let me draw it again, but a bit more accurately, so just to give me a little bit of help here. So there's the y-axis, there's the x-axis, there's 1, 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7, 2 would be here, and 7, 10 would be up here, and there's the line -1. And it's kind of nice that they're lined up, because if that's a chord and I draw a perpendicular bisector, so if that's at 2 and that's at 10, then the perpendicular bisector would be here at 7, 6 in the middle. So if I go across here at 7, 6, I've got a third point here at 7, 6, sorry. I've got a third point here, -1, 6. That's on the circle, and that's actually a tangent there. And okay. So, I mean, I have 3 points on the circle, so I know I can solve it, but I'm just thinking what would be the quickest way to do it. So what I'm thinking is, the reason I know this is on the circle is because I know that this line here, which is a normal, must pass through the center of the circle. So it's kind of like this. You have your chord here, and you have this perpendicular normal to it, and I know that must pass through the center, and then it goes through the center and hits the circle on the other side. But I guess, actually, now that I think about it, I don't know for certain. No, I do know for certain that this has to be the contact point, because these are parallel. I think so. Let's just think about this. Let's draw a full circle. So if I have a vertical line here, and I know these points here, I should draw that a little bit better. I have a vertical line here, and I know these points here, and I get the middle, and I go across. I know the center will be on this line, and I'll hit the other side of the circle where the tangent is. So I really think it's going to be this point. I really think so, but I won't know for certain now till I solve it and check the answer. So what I'm going to do, there's some point here on this line that will make this distance equal to this distance, which is supposed to be the radius of the circle. So this total length here is 8 units. So if that's r, then this distance here will be 8 minus r. Yeah. This height here, well, actually, I won't use the letter or just yet. I'll just say the letter x. So we'll just call this distance here x, and this distance here will be 8 minus x, and that distance there is 4. So this distance here should equal this distance here. So we have x should equal square root 4 squared plus 8 minus x squared. Let's solve that. X squared equals 16 plus 64 minus 16x plus x squared. So they cancel, and I get 16x equals 80, which is good. So therefore x is 5. So that would make this 5. and that would make this 5. And of course, you can see what's happening here. That would make this side here 3. So I have the center of the circle. If that's 5, then here to here is 4. So that would be 4, 6. And the radius is 5. So I think the circle would be x minus 4 squared plus y minus 6 squared equals 25. Now I'm going to check the marking scheme. Okay, that's that question done.